Okay, welcome back, everyone. Right, today we are going to do the first workshop. So, if you are using your laptop, please make sure that you have Rhino installed. And if you are using desktop, you can open the Rhino now while I'm introducing the workshop. Right? I think there shouldn't be an issue that if you are using the desktop here. We did a class last year here, so everything was fine. Okay, so if you go to Canvas, I published 3 modules here. The first half of this class, we will go through these 3 workshops. And this is the first one we are going to do, the PLSV. There's a funny name, but it's just like a point, lines, surface, and volume. So you can go to check the handout here. Okay. So I'm going to talk about the handout a little bit, and we start the workshop. Let me switch to the full version. Okay, so this workshop is about points, lines, surface, and volumes. They are the basic elements in computer-aided design or in general in geometry. So I think that would be nice if we can go through these basics, either in both in Rhino and in Grasshopper, so we can practice more concepts and the data representation of these things. What do they mean? And this is an example about what we are going to do today. So this is a very elegant design. It's done by the Urba Folia in 2013 in the park, the park Mother Stevens. Mother Stevens is a very famous architect, and he did a lot of buildings. And this is one of the gardens. This garden around one of his building. So that's almost like a memorial park for him. And this is a tunnel. So you can see this kind of complex shape. It's actually not very complicated because if you take a close look, you will see this is actually square or rectangle, right? It's part of the rectangle, and you just keep rotating it and keep moving it. So you create this kind of space. So that's what we are going to do today. We start to use simple geometry to and apply transformations and on this geometry and create a space. So for example, that rotation is one of the transformations. Moving or translation, we say translation is like moving, is another transformation. So today we are going to do something very simple exercise that we keep adding the transformations on simple geometry to create complex shapes, right? And so we have 3 days. I leave 3 days for this workshop. So that's today, Tuesday, and Thursday next week. And we will, the due of this project, the assignment is September 5th, 9 a.m. Because I want to share the works with everyone that typically I share the works that you submitted with everyone in the class. So I would like you to submit your work by 9 a.m. so that I can prepare your assignment. There are 4 files you need to submit. The first thing is a Grasshopper file. The second thing is Rhino file. I will talk about these 2. And the third thing is 16 6-inch by 6-inch images. Okay, so it's a square images, and I will show what it is in the example, and one PDF that is composed with these 16 images. All right, so it looks like this. 16 images in an array, 4x4 array. We have 4 variations, and we have 16 variations in total, but we have 4 series. Every series have 4 variations. Okay, so that is a naming convention. Please put your last name, your first name, and assignment 1. So this is a Grasshopper file, the GH file. This is a Rhino file, the 3DM file. And please put these 16 images, independent images, in a folder and compress it as a zip file. And the final one is a PDF. So this is a PDF file, right? You can also go to the canvas. I show in the same module, that the first module here, I put a sample. So that is the PDF file I'm looking for. So 16 images and put them together like an array. All right. I don't have the template for that, so I think you don't need to. You don't need a template. You just put 16 images together. I will encourage you to put some parameters here later. All right. So, but anyway, that is an example of what we are going to do today. So let me open my Rhino. Okay. So this is what we are going to do. Right? It looks complicated. It looks complicated. It looks, like a lot of lines, a lot of points, a lot of surface, a lot of volumes, and the shape looks, the geometry itself is very complex. That this one, the surface is very complex. But how do we do this? Is actually very simple process. Just like I said, we keep adding transformation on the simple geometry, and we can do this thing. So that is what we are going to do for today. And we will use 3 days workshop to cover everything here. All right. So please open your Rhino. Let's start. So when you go to Rhino, you will see 4 windows. And your interface might be a little bit different from mine, and your background might be gray color. It's okay. Because personally, I like a very clean interface, so I clean all of them. You will see the buttons here. How about this thing? Let me restore the toolbar so I can have the same interface as yours. Right. So defaultly, it looks like this. The background color is gray. You will see a lot of things like that. Typically, they are the V-Ray applications. So if you don't need it, you can just turn it off like this. Okay, so I don't like my Rhino looks like a dashboard, like airplane. So I typically turn off the things that I don't want. So there are some tools that we will use. Mostly that we won't use this geometry tool here. But right now you can see many different tools that you can create geometry, including here. They put another toolbar here to, like the thing you commonly use here. And if you use other software like SketchUp or AutoCAD, Revit, they are very similar. So you just like a modeler. When you say modeler, it's like a tool for you to model things. So you create geometry. And there are 4 different views. One is top view, front view, right view is side view, and then perspective view. You can use your right click to rotate your window, or you can use the middle button, so like a wheel. You push it, you can pan it. If you don't have the wheel, you can hold the shift and use right click to pan the window. All right, so hold the shift and right click to pan the window. If you don't hold the shift, you will just rotate it. Use the wheel to zoom in, zoom out. If you don't have the wheel, you can use control. Oh, sorry. No, you have to have a wheel to zoom in, zoom out, right? All right. So that is the basic operation of your mouse. You can switch to any window you like by double clicking the tab here on the top. For example, this one, if you want to maximize the perspective window, You double click it, you become the full window for you. You double click again, you'll go back to full windows. You can customize the numbers of windows as you like. That typically I don't do much. And top view is top view. You double click it, you can switch the window, right? So viewport. So now I'm going to maximize my perspective window like this, right? We can try something very simple. In this class, we are not going to use very complicated geometry tools. In Rhino, you will see on the left, you have some basic tool like you can create a point. Here's a point, right? You click the button and then you can go to your canvas to click it and instantiate a point. You can use a space key to instantiate, to activate the previous function you were using. So for example, I use point. If I want to use point again, I can use a space key to instantiate the points again, right? Like SketchUp or AutoCAD, you know that right selection is select the part of this, left selection, they are different. Okay, so they are very similar. What I meant is let's use, so there are some other tools like polyline, curve line, circle, ellipse, arc, rectangle. Let's use rectangle tool. So here's a rectangle tool. You can click it and you can instantiate the square or the rectangle on the XY plane. So look at this. The first click and the second click, you instantiate a geometry. So when you use right selection like this, if you just select the partial of this geometry, you won't select the shape. But if you are using the left, right to left selection, you will select the geometry. So very similar to all the CAD tools. If you are using other CAD tool, this is basically the same, right? You can move it, select it, and move it, type M-O-V-E. You can move it to anywhere you like. Or you have gumbo like this one. Typically, I don't use this thing because sometimes it's confusing. It's more like a straightforward operation that you can move, fix the direction you want to move, right? If you don't see the gumbo, then your Rhino is okay. It's okay. It doesn't matter. So you just need to go to the options to turn it on. But today, let's not go through the detail about these options. So you can use move. If you want to fix to the X direction move, you can hold a shift. So you will become orthogonal, right? If you want to move vertically, that means Z direction. Here in your Rhino, here's a message window, and you can see the prompt that Rhino sent to you. So here's a vertical option. You can click it, and you become vertical. It fixes the direction to do the vertical, right? So this is transformation. You can apply the transformation on your geometry. And Rhino, one of the most powerful things of Rhino is his complex modeler. For example, you can easily create curvature in Rhino. We call it NURB, N-U-R-B. So the NURB geometry is more like a free form. It's more like the shapes with a lot of curvature. So you can do this thing. For example, here's a sphere. Where is the sphere? Oh, it doesn't have sphere. It's okay. Let's do. You can. Oh, sorry. You can instantiate the geometry by clicking these buttons here or something here. That if you go to the tool here, you can see curve tools that mostly about the curves. And here's a tab about surface tool. So you can create surface here. Solid tools that you can create solid here or do solid operation like Boolean operation. Sub-D tool, that is a new thing for Rhino that I won't use this thing, but if you are interested in this thing, you can talk to me later. This sub-D is like a subdivision. It's more like in between pixel-based and vector-based representation, which is complicated and pretty new. Mesh tool. Sometimes we'll use mesh tool, but if you are using mesh, you have to be aware of the geometry because it'll be very messy. There are some basic rendering tool. You can have your own plugin if you you can use Revit as a default setting here, or you can use Rhino engine, that rendering engine. This class we don't demand higher degree, advanced skill of rendering. You have your own rendering setting in your laptop. Just use them. It's fine, right? So other things that are very complicated about the data, anything that's I'm not going to go. We are not going to do these things here. So you can use the surface tool to create some surface. You can use solid tool to create some solid. For example, let's use the sphere tool. So if you change your tab, you will see the tabs on the left is like a shortcut for you. You can have other tools here. For example, you can use the ellipsoid to create a tool like this, right? So create geometry like that. And you'll be wondering that why it looks like just lines. It should be solid because in Rhino, you can go to change your rendering here. So go to your tab. Here's a pull down menu. You can change the representation of your model. So now we are in a wireframe. That's default. And here is a shaded. So you can see the surface now. If you change to shaded, that's the surface. Okay. If you want to zoom like nicely to your model, you can select the model and type ZS in your command window, and you will have a nice zoom view. That's pretty important for me. That if you are far away, you want to go to focus on the thing you want, you can select the model you want and type ZS and press enter. You will zoom the selected object. All right. And there are some other tools like create a box, anything like that. I will leave you to play with this tool. Typically, I use shaded view. You can do rendering. There's a in real-time rendering. It looks very bad and it's very performance consuming. So I don't use rendering view much. There are some ghosted view. That means a combination of wireframe and shaded. Here's an X-ray. I don't know what's the difference between X-ray and the ghost view. For me, they are the same thing. It's just like a little bit different rendering skill. You can see they are very similar, right? So I don't use them much either. Technical view is important for me. Technical view is a line drawing view. Okay, so sometimes it's gone because if you see, let's focus on this box. You will see this box. It becomes a technical line drawing view, right? So when we are producing our final deliverables, technical view is pretty important, right? So you can see the line drawings, okay? Artistic, that's just the one I never use. It looks really bad. Pen, another bad thing. Arctic is a little like rendering. I know a lot of people like use Arctic to represent their work. Just be careful. This is not very good. It's good, but just be careful about the rendering style you are using. They give you a rough sense about the materiality, but not very accurate, right? Ray trace is like a rendering tool again. Ray trace means that it's calculating what's the surface on you are looking at. So I never use this thing. So let's go back to the shaded, right? And you can also go to fix your camera. So now we are in the perspective, right? It's a perspective. So it's like a 2-point perspective. So it's 2 point. So you can see these are parallel. If you go to the tab, you pull down here, you can see set view. Oh, sorry, it is a 3-point perspective. You can go to change your view, even though you are in the perspective. You can change to top view. So if you double click, you have two top view windows, all right? So be aware of this thing. You can set the view to left, right, front, back, any kind of view you like. Perspective, you go back to the perspective view we have. And here's a two-point perspective. It looks a little bit weird, dramatic. Never use this. Here's another thing I think is important, is isometric view. So isometric view, you know isometric view, that like isometric drawing you did in the studio. Northeast, northwest, southeast, southwest, you can fix the view so it becomes isometric, right? You can rotate in isometric view, but once you rotate, the angle is no longer southeast or northwest. It's kind of fixed angle. If you want to fix the angle again, you go to set view, isometric, set the angle again, right? So you have the 30 degree isometric view, all right? So typically I would do this thing, technical view and isometric view, to produce my work. That is production. We will talk about production later, is a lot of detail. So let's go back to the shaded mode and perspective view, right? So they're very simple, very straightforward, nothing else. It's just like we are not using much. Probably we already go through all the basics we need in this class. You can be very, very professional in modeling that, okay, I know how to create this kind of geometry, I know how to do this thing and that, but this class, you don't have to worry about that much about the advanced modeling skill, because most of the modelings will be done in Grasshopper, all right? So that's what we are going to do. So let's shift to top view by double clicking the tab, go to top view, all right? So when you shift to another window, the viewport, every viewport has its own rendering settings. So we will, if you go back, now we switch to top view. The wireframe is a default. I will change to the shaded mode, all right? And that's delete what we just created here. Today we are going to create something very, very simple. That's just follow me. Please use rectangle tool. You can just type in the command line, type rectangle, right? Rectangle, and press enter. And let's hold the shift to create a square, right? So if you don't hold the shift, you have the actual rectangle. If you hold the shift key, you will have the square, all right? So let's create a square first. That's it. And let's go back to our perspective view. Select the square, type zoom as to have better zoom. All right, that's it. Next, let's open Grasshopper. So go to command line, type Grasshopper. In the beginning, Grasshopper was a plugin of Rhino, but because Grasshopper has a huge success, so Rhino acquired Grasshopper, so now it's inherited. So you don't have to worry about this. All right. When you open the Grasshopper window, it looks at this. All right. So just hit the close button if you see this message. No bother on this thing. There are previous files you opened, so that's not the thing we are going to do. All right. So this is a Grasshopper window like this. All right. And this is the place that we are going to use Grasshopper. So Grasshopper is a programming language, actually. It is programming language, but because architect, designer, they are not trained as programmer like C++, C#, this kind of programming language coder. So the inventor of Grasshopper, they think, okay, that if we can introduce a graphical interface for the designer to play with programming language, that'll be great. So this is interface for us to create, to code, to program, right? So here is a Grasshopper. You can see some tabs here, the ribbon. They call it ribbon. There are some other some main tools. And also you can install the plugin here. But today we are just use the very simple one. All right. So you have two windows. One is Rhino window. One is Grasshopper window. So be careful. This window is, we call it symbolic domain. Okay. So in Grasshopper, they only work with numbers, these numerical values. Anything in this window is symbolic. All right. This window, it is, if we want to be really, really pure about this concept, it's still symbolic, but however, this is a visual window. So this is a visual domain. The thing you look, you see, the shapes are here, right? So this is more like numbers. This is more like shapes and geometry, all right? So the actual geometry. There is a channel between Rhino and Grasshopper, so they can communicate to each other. All right. So there is a channel that they implemented. So we don't have to worry about this thing, but just a basic concept. There are two different things. All right. So you did something in Rhino, you can grab what you create. For example, this square. You can grab this square into your Grasshopper to do operations that would go through this window, this channel. All right, let's do this thing very simple. All right, let me put it into the half window, and this is half window like this. All right. Okay, so just follow me. In the Grasshopper, please double click on the canvas, and you will see a small window. Enter a search keyword. Right. So that's use curve. Right. So type curve. When you type curve, you will see a little small black hexagon and all the other suggested options for you. So this black hexagon is the thing we are going to use. You can click it. You can zoom in. You will see a small thing like this. It looks like a battery and is a component. So you can instantiate components in this way by double clicking on the canvas, type the keyword and code it out. Or you can grab the components from the ribbon. For example, the one we are using is the curve. So here is a params here, the first tab. You can grab the components like this one. We are going to use curve, this one, right? So you can put it down, geometry, put down the menu. Here's a curve. You can drag it to your canvas, and you can instantiate the component. Very straightforward. If you don't like it, you can select it and delete it, right? So the one we just used, this one, the black hexagon one, if you see anything in Grasshopper in black hexagonal shape, is a container. Okay, so it's a container. It's a container to contain the geometry or anything you want, right? So in this case, this container can only contain the geometry, which is curve, right? So what I mean contain, or what do you mean contain the things? What you are talking about? For example, that this is what we are going to do. We just created a square curve. This is a curve, right? This is a curve in your Rhino. However, this is in Rhino. It is not in Grasshopper yet. If I want to use this square, I need to put it into Grasshopper. We call it associate. We associate this geometry into Grasshopper so that we set up the channel. So how do we put this thing into Grasshopper? You can go to hover over on the component of this curve container and right click. You will see the pull down menu like this. Please go down. You can see set one curve. You can click it. If you have the full window of Grasshopper, you automatically shift to Rhino window. And now you can select the curve in your Rhino. So you select the curve. Once you select the curve in Rhino, you will see the color of this component changed from orange to gray color, light gray color. If you see any component in light orange color or red color, that means there's something wrong. So let me show you again. So this is something wrong. And here's a small message. You can hover over on this small dialog window, it will tell you that what's going on here. For example, they say, okay, this is empty. There's nothing here, so that's why it's orange color. Once you associate the geometry here, put it into the geometry, the grasshopper, sorry, it becomes gray color. That means, okay, it works normally now, right? So the data of this curve is input into this container now. So how do we know what is inside? This is a very important component. It's called panel. This kind of thing is like a stick node, and you can drag it out from the ribbon, associate it, instantiate it, and here's like a small monitor for you to check out what is in the component. So the thing we are going to connect, the way we are going to connect the grasshopper component is like this. It's just wiring it. So you will see this component has input, there's the left hand side, output on the right hand side. So remember the diagram we showed last time is a function. It has an input and it has an output. The input here is from the channel between grasshopper and the rhino, so there's no input here. You can output the thing to everywhere you like. So you just go to hover over on this small half circle. You can drag it and it becomes a wire and input to any other components you like. So let's put it here. And you will see there's a message here in your panel. It says referenced polyline curve. I saw what is inside. The inside is a reference that means that the thing in Rhino, you are referencing a polyline curve here. So this is a curve data inside. All right. You can delete it. We're not going to use it. All right. So that is the very first thing. Everyone is okay? Okay, I think it's very straightforward. Secondly, all right, remember the example I just showed that I want to create like a tower. That how do I do it? So this is a thing we want to do. I want to add a transformation on that. I want to copy it, right? Copy it vertically to have layers, right? So that's used. Just follow me. Double click on the grasshopper and type move. When you type move, you will see this small orange arrow and 2 points, this move, right? Sometimes you have different naming here because I'm using the full name display, which is to make this component very big. Defaultly, you are not using the full naming system. You can go to display. Here's a draw full name. Again, here's a display on your grasshopper. You can put it down. Here's a draw full name. If I don't use full name, it looks like this. Probably that's your default setting. If you want to see a full name of the component, you can draw full name. Today I will use full name just in case. So you can have full name that you know what it is. Maybe next time I will just change it to the short version. But just be aware of that. A heads up that Rhino and Grasshopper, they are so bad at naming system that they change names a lot in the short version and the long version. Sometimes they are completely different. So just be aware of this thing, right? So this is a component that is, we can apply the transformation to move the geometry. You can use this component to move your geometry. And this is one concept in Grasshopper that every time when you apply the transformation on the geometry you set up, it always follows with copy. Because if you move the geometry, really move that geometry, that means you are changing the previous status here. So for example, just follow me. Let's move this curve, right? Let's put this curve into the geometry port. So the move component has 2 inputs, 2 outputs. The first input is geometry. That means what kind of geometry you want to move. Okay, just give me the geometry, right? So when you put this geometry in, you will see in your window default setting is the motion is in the Z direction. I just lift it up. Okay, so this default setting, even though you don't have any input, it has a default input already inherited inside. But you can see you have two square. If you click the previous one, it's still there. If you click the move one, that means the one you moved, you create another geometry. It copied. So any kind of transformation you use in geometry, in Rhino, the transformation you use in Grasshopper, it always have copy, because otherwise it has to go back to change this component, right? Because this component is just you did in Rhino. This is square on the floor. If you want to really move it, this operation has to change it, go back to change itself. That is not allowed in Grasshopper. Grasshopper doesn't allow you to go back to change all the history before. It can always from left to the right. You have a data 1 become data 2 become data 3 become data 4. If you want to use data 4 to change data 1, sorry, you cannot do it. It doesn't support loop. Because that's complicated things, you cannot go back to change the previous one you have, because that'll become a loop infinitely, changing things. You use 4, change 1, 1 change 2, 2 change 3, 3 change 4, 4 change 1 again. So that'll become a positive or negative loop, and you keep changing things that will get into the problem of infinity. So Grasshopper doesn't allow us to do anything like that. So that means if you want to move the actual geometry, sorry, you cannot do it. The only thing it can do is you give me a copy, I move that copy. All right. So that is the logic of Grasshopper. Right. So you will see the previous one still here, and the moved one is here. All right. You can input the motion that you want. Motion means what kind of moving you want me to do. So if you hover over on the input of this component, you will see some message from that. That information says 0010. If you hover over on that, you will see the default setting is 0010. If you don't input anything, there's a vector. So vector is a 3 digit component that specify the amount, the magnitude, and the direction, right? Vector is just like the vector you learn in high school math. So it has a direction. In this case, is like a 10, 10, 0, 0, 10. That means in the Z direction and 10 units, right? So this square is moved in the Z direction with 10 units, all right? So very simple. You can specify, you can identify you can design your motion here. Right? So now we have one moved square. However, I want to copy and move it like a lot, like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to create 10 squares that's in the Z direction. I just want to keep copying it. So here, just follow me. Let's instantiate a very important component. Double click. Let's use series. When you use series, you can when you type series, you can see the small icon is like a 3 small numbers 0, 1, 2 here. This one we are going to use. Series is a super useful component that the thing it does is to create a series of numbers. So you can use panel to check out what's the input, what's the output, right? So if you don't have any setting, any input of the series, like 3 inputs, it will give you the default setting output. Star means I'm going to generate a series of number, right? 0, 1, 2, 3, 4, 5, 7, 8, 9, like this one. But star is like which number you want to start, right? So you can double click. Just follow me. Let's use a number slider. So like 0, type 0, and press enter. You will have a number slider like this. Number slider is a very straightforward component. It just output a number. All right, just give me a 0. I give you a 0. So like this. Number slider has something setting that you can do. If you look at the number slider, you can double click. You can see the small slider here. That means you can output different numbers here. if we are using the panel. So you can reuse this panel by just input this wire into this panel. It will automatically disconnect the previous connection, right? So you will see, okay, now you are outputting the number, the value is 59. All right, so you can change that. You can see it's real-timely change the thing, right? So you can output different numbers, right? Let me delete this thing, right? And there are some setting of the number slider. You can double click on a name here, double click here. You'll get into the setting of this number slider. Okay, so you can change the name like a start number. You can name it in any way you like. You have a name, expression, or the grip style. Let's not talk about this thing. Here is slider accuracy. So the rounding is like you want the real number or you want the integer is n. So far is integer. You want the even number or the odd number. I never use even number or odd number. I always use R and N. R is a real number, N is integer. So if you want to have the fractional part of your number, you have to go to your select this real number setting, and then here's a small setting for you to specify how many digits after point. Okay, here's a 3. You can go to 0, that means integer. 1, just 1 digit after the point. 2 digit after point. Typically I use 3. All right, and here's a minimum number of this slider, because slider has a range. You cannot output any number. So here's a minimum value of this number slider. So far is 0. The maximum is 100. I'm not going to change that, right? The range is 100. And here is a numeric value that right now, what is the numerical value it's outputting right now. So these are actually the sliders. So you can change to any number you want, and you click OK, it go to here. So it's actually the same thing that you did here, right? You can directly input the number, because I want the 31.804. It's so hard to drag the exact number you like, right? You can double click on this slider, on this part. You can direct give it a number like this. Put the number and press enter. You will have the exactly value of the number, right? So in this case, I want to start from 1. I can double click and set up the 1. I want this series of numbers start from 1, right? Let me use the panel to check out the output. So far is 0, 1, 2, 3, right? If you input the slider to the start point, you will see the start number change to 1. It's not 0 anymore. If you can go to see if you change the number here, it's changing. So this is a start number, right? So where you start. And the step, what's a step? So step means that how much value in between, right? So we can instantiate another number slider. A number slider, if you instantiate the number slider, there are some small tips. You can set up the minimum and the maximum directly when you are instantiate the number slider. So you can type, I want the number slider, the minimum value is 1, the maximum value is 10. So I put 1 dot 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 3 dots and type 10. So 1 dot 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 10 and press enter. You will have a number slider that is from 1 to 10, right? And I want the step is controlled by this number slider. So if I go to 2, you will see the step is 2, 0, 2, 4, 6, 5, 8, blah, 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 right? The last one is count, how many numbers you want to output, right? So I want to output at least 50. So I want to do another number slider. I want to start from 1 to 100, right? I put it into the count. So far it's 1, so I output 1. I want to have 25. Press enter. So you output 25 numbers, right? Here's the thing that we want to be careful about is you can see the index. So in the list, the number, the series component, it generate a list. So it's not only one component. It's not only one thing. It's a bucket, has a lot of things inside. All right. That's a 25 numbers we are generating right now. All right. Every number, every item, we call it a list like this. Every item in the list has an index and the value. All right. So on the left hand side here is your index. On the right hand side is the value. All right. So I have an item 0. My value is 0. I have item index 1. I have value 2. So the index is how you access the item, right? So give me the index 2. Give me the number 4 item, number 3 item, right? So you use the index to access the item. And the item can contain different things. Sometimes it's a number, sometimes it's a geometry. But anyway, there's a list. It has an index. The thing we need to be careful is the index always start from 0. All right. So this is like some long time ago, the computer scientists, let's start from 0. So let's start from 0. So that's a convention of the programming language. We always start from 0. So be careful about this thing. The first item is index 0. So that's a thing we have to be aware of. All right. So let's move on. I'm going to delete this panel. And now I want to set up my number. I don't want the fractional number here. So I go back to change it to integer because sometimes it causes problem. I want to step just 1. I want to output 25 numbers. All right. And now I want to create 25 different vectors so that I can move together, move this geometry together. So just follow me. I want to create a z direction vector. So just double click, type z, or you can type unit z. Hey. So this vector only in the z direction. It has an input that about how many units you want me to move. You want me to set up as a z direction. So if you use the panel, you will see the output is 001. That's z direction vector. So it's 1 unit. So you toward the top, right? And then the unit is 1. So here, there's something we have to be careful is that the series we create a list. You see this wire changed. The previous one is a solid wire. That means only one thing. Okay, one curve, go to here. So it's a solid wire. If you are outputting multiple things, it becomes this kind of hollow. There's a double line wire. That means you have many things here. All right, many things here. So far, we are outputting that many things. We have a list, a bucket. There are 25 things in this bucket. We output the bucket, entire bucket. All right. So that is a thing we output. And now, if we output this thing into the z direction, you will see the z units we create that many units, that many vectors. Sorry. 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 3, 0, 4, 0, 5, because we put the whole bucket to the another component. So this is a very important feature of Grasshopper that even if you give me a list, I give you a list output. For example, this is z unit. If you give me one number, I give you one vector, right? And if you give me 10, just one number 10, I give you a vector which is magnitude is 10 and in this direction. If you give me 10 numbers, I give you 10 units. All right. So that's how we process this list. All right. So now we have 25 vectors here. 25 vectors here. And let's do this thing. Let's output this unit vector output into the motion. and you should see the result like this. All right, let me explain here. You can move your components, freely in your Grasshopper canvas. So just like we said, if you give me a list, I output a list. If you give me one vector, I move it once. If you give me 25 vectors, I move it 25 times. Okay, so the output will also become a list. If you go here, use the panel to check out the output of the move component, you see the geometry, use the geometry. There are 25 curves, right? There are 25 curves. So just like we said, it copied 25 times. Every time when you apply transformation, I copy once. You give me 25 different transformation requests. I give you 25 different geometries, right? Okay, so there are 25 squares here. You can change it here now. You can go, for example, I want to change the steps. 1, 2, 3. You can change the distance in between because the series component we are using is to generate the number set, right? So if you check out again here, by adjusting the steps, you can have different magnitude of the moving. Yes? Sorry, let me see. You turn them off. Oh, you turn it off. Okay. Oh. Yeah. Yeah. Hey, everyone has these squares. Hey. So, I will talk about the turning on and off later. Here is a transformation we apply, right? So we have this series number. We use this number to generate that that many vectors. We use these vectors to move and copy this square, and so we have that thing. So here we can change the number of sliders here. That if I want to have 50, it become 50. I want to. So this is a gap in between, right? 4 units for each layer, 6 units for each layer, like this. So I'm going to keep it like a 25, and this is just 5. Looks more like a tower, right? Okay. So here's a very important thing that about the geometry. So you say, Kurt, I know that I want to move it. I want to discard the first one because this is the original one. How can I get rid of this thing? You cannot delete it. The only thing you can do is to turn off the preview of this geometry. So when you highlight the component in Grasshopper, you will see this component become green color, and also the geometry become green color as well. That means this one is the one you are selecting. And if you go to here, click this move component, you will see all this geometry that you moved are highlighted in the green color. So if you say, I want to get rid of this original geometry, how do we do that? You can go hover over on the component, use the middle wheel, click. You will have a dial like this, the wheel, and there are some shortcut to do. So here is you can see a small icon that with blindfold that is disable the preview. So if you click it, it becomes dark gray color. That means you are not previewing it, so you cannot see it here. You cannot see the green color here. The red color is not a geometry yet. So even though we see that the geometry you create here, but beware of that, it's not the actual geometry like we did, like this square. No, they are just preview of your data. Again, this Grasshopper window is a symbolic data window. We manipulate data only. We are not creating actual geometry in your Rhino, right? So we just use the data to create things. However, these data, they're just data only. They are not the actual geometry in your Rhino. So you cannot select here. There's no geometry. You cannot select anything in your preview. All right. So they are just preview what you did in Rhino. They are not actual geometry. If you want to have the real geometry in your Rhino, you can do this thing. Go to the move component, this one. Use the middle click. Here's the sunny side up add. That means it's called bake. So you can click it and it will bake the real geometry in your Rhino. So you can select them. Right. In the Rhino, if you don't like it, you can go to your Rhino window, Control Z to unbake it. All right. So there's no geometry at all. Right. Typically, I don't use the middle wheel, the middle button to bake it. I always use right click. You can hover over on the component, right click. There's a bake option, exactly the same. But if you use right click, you can see a pop-up window like this. There's an option that you want to group the thing you bake. I always check yes, please. So I check this thing and I click OK. So they are grouped in Rhino so that I can use them. You know, I don't have to drag all of them or one by one. I can drag all of them together. All right. There are some other settings in this kind of control wheel. One thing is the preview or unpreview. So this one is unpreview. If you want to turn the preview back, you can use this enable preview. There's a head figure without the blindfold, and you will see the preview again. In this case, there's an actual geometry we create in Rhino, and also when we grab the data in the component, it also preview the data. All right, so it's a kind of multiple folded here. So we have an actual geometry here. We grab the data into the Grasshopper, we preview it again. So you can see the green one, right? You can, if you click on this curve, you can see the green one. It's previewing the data again, all right? If you move the geometry in Rhino, it will follow you. So for example, you can select the geometry, which is a square in Rhino. We type move in Rhino. You move it to anywhere you like, and the data will just change immediately. So all the data will just change. You just follow the geometry that you input, right? So when you change the input, the result will change, right? It's always follow the geometry, the data you input. Okay? I'm going to turn off the preview of the curve, input curve. I'll leave this thing. So far, so good. Let's speed up a little bit. Okay, now I want to rotate. Remember the exercise we did that I showed? I want to create a square, and then I want to move it up, and I want to rotate everyone. All right, I want to rotate everyone with a certain angle to have a gradient rotation like this. All right, so that's what I'm going to do, like this one, right? So here I'm going to use another series. Okay, so just follow me. Series. I want to create a series of numbers that specify the rotation angle again. All right. So here, this time, I want to create 25 numbers as well. So I'm using the same slider. If I have 25 squares here, I want to rotate 25 times. So I don't want to instantiate another slider. I just want to use this thing together. So in case if I change the number here, it will change the component here as well. So I don't have to change one by one, right? I can associate them together. So I use count. I want to generate 25 numbers as well. And the start, I use 0, 10 as a start. You can copy paste the component in Grasshopper as well. So I copy Control C, select the number slider, Control C, Control V. You can copy another component. You can move it. Now I'm going to put it into a step, right? And I'm going to change the setting here. I want to change it to the maximum from 0 to 360 degree, because I'm going to use this as a rotation, right? So this is the number I want to create, that I want to create 25 numbers. And the first one is 0, I don't rotate. The second one, I want to rotate 3 degree or 66 degree or 7 degree. Okay, so here I'm going to put maybe 10 degree. So I'm going to use series component to create a series of number. The first square I want to rotate 0 degree. Second square I want to rotate 10 degree. The third one 20 degree, blah, 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 all the way to 22 and 40 degree, right? So the series of number, okay. So we are going to use another component called rotation. Okay, rotation. So double click, rotate, not rotation, sorry, rotate. You see that how bad this naming convention is, that they have couple components, they are all called rotate. Please find this one, a small trapezoid, orange one, and with the rounded circle arrow, this one, rotate, right? This is another component that we can use to transform our geometry. So that is rotate. So here is the thing. We just said, remember I just said, if you give me one number, I give you one item. If you give me a list of a number, I give you a list of an item, right? How about this thing? If you give me two lists, right? So remember that we have a square. I want to move it. If you give me one vector, I move it once. If you give me 25 vectors, I move it 25 times. 1 to 25, right? You give me one square, I move it 25 times. But now I have 25 squares, and you give me 25 angles. How do we go about it? I do every one for 25 times or something else. So in this default set, in the structure of Grasshopper, if you give me two lists, I will pair them automatically. So first square, pair first angle. Second square, pair second angle. The third square, pair the third angle. So here's a thing very important, that if you have 25 squares, but if you give me 26 angles, that will mess up the data structure. It doesn't know what to do. You will still do it, but the last angle, you go back to put it into the first square. So it's like a wrap structure. I get 25 squares, 25 angles, fine. But I found one more angle here. What should I do? I put this angle into the first square again. So it's like a cyclic system. So be aware of this data structure. If you want to operate things like this, match the numbers. All right, 25 squares, 25 angles. That's why I use the same slider here. I can make sure that I generate 25 angle for 25 squares. So I use the same number slider here. So I don't have to change. If I change it to 30, I don't have to come back here to change another number slider to 30, right? I can change them at once, right? So let's move it. Now I want to rotate the geometry. However, I want to rotate the geometry with the center of the square, right? If we can do it, we can put these 25 squares here and 25 angle here. That means the angle, you will see a very messy thing, right? It's rotate everywhere, because defaultly the center of the rotation is 0, 0, 0. Okay, if you don't give me any rotation center, I would just defaultly do 0, 0, 0 as your rotation center, right? So here we need to do the center of the square. I want to rotate the square with its center, right? Its centroid. So here's another component we are going to use. Please follow me. Area. This is a very useful component as well. You can see this M square, this area component. Give me the geometry. I calculate the area for you, and the byproduct that it does is I'll give you the centroid as well. All right. So let's use this thing. So geometry. Go to geometry. So you can see once you input the geometry into the area, you will see a lot of centroid here. So this is the center of the first square. This is second square. This is for the third square. So the centroid is a point. All right. So we are going to use these centers as the rotation center. Again, it's a pairing, right? If you give me 3 lists, 25, 25, 25, I will pair them for you, right? So that's put as the plane, right? So another naming convention, the very confusing plane means working plane. In this case, that is the center that we are going to use, the rotation center. So sometimes they use center, sometimes use a plane, sometimes they use point, a lot of different names, but just beware with this kind of thing, it's okay. Once you input this plane, you will see, okay, they are rotating with the center that you just set up, right, like this. However, they are still very messy because we forgot one thing is the angle. The angle is defaultly set up as radian. We are using degree, so they are different. That radian is 0 to 2 pi, right? So we are using degree. So here, please go to angle, right click on the angle, the input. You will see some options. Here's a degree, a small circle one. You can change the input type. All right, so that's changed to degree. All right, so you will see in your Rhino, they are very messy here, right? It's like, okay, I have the squares that not rotated yet. I have the square that rotated already. It's very messy, hard to see. So here I'm going to turn off the preview of those squares before rotated, right? So I'm going to turn off the preview of this moved. Also, I want to turn off the preview of these centers as well. So I go to use the middle click, turn off the preview. So that is square. You rotate. You can play with this number slider now. You can have like I just use 10 degree, right? Everyone is 10 degree. I'm going to use 6 degree. It's just every time it's just more smooth. 60 degree only. You can use 3 degree. It's even smoother, right? Everyone is okay? Okay, everyone has these rotated squares, okay? Let's do one more thing, and then we can call it a day. All right, so you are very familiar with the series. Let's use another series because I want to scale it down. I want to use scale. So I'm going to apply 3 different transformations. I want to move it, I want to rotate, I want to shrink it down. I scale it, right? So that's another thing we want to do. So we use series to create 25 different vectors to move it. We use series number to create another 25 degree we rotate. Another thing is I want to create 25 different scale factor. So like a smaller, right? And that gradient, like small and small and small. Okay, just follow me. So another series. Again, I want to use the same number here, right? 25. Because if I create 25 squares, I want to have 25 vectors to move. I want to use 25 degrees to different degrees to rotate. Same as the scale. I don't want to create 26 or 20 or 30 other numbers of the scale factors, right? So I drag this one all the way to the count of the series here. Okay, and the start I will give it as 0.1 dot 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 1. Okay, because I want to scale it down, but I don't want it to be scaled to 0. Because if you are using scale component, you give it 0 number, you show you the error message. Okay, so just be careful. I want to set up the minimum number as 0.1 as a start. And the step 0.1 dot 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 10 again, right? And now you can see, use your panel to check out the output. Okay, the first one is 0.1, 0.2, 0.3, all the way to the 2.5. Okay, Let's use this number as a scale factor, and we see how it goes, right? Double click scale. So if you are typing scale, there are two different scale components. One is scale NU, one is scale. Let's use this scale. Let's not use scale NU. NU means non-uniform that we will be using it later. So just scale. Okay. Same thing, has three inputs. Give me the geometry you want to scale. Give me the center of your scale center. When you are using the SketchUp or anything that you scale the geometry, you ask you to click the reference point, right? Another reference point to scale it down. Same as here that you have the center as a scale center, all right? So otherwise you would scale somewhere else. We can try it now. So that's to the geometry. This is the rotated one. Go to the geometry, and you will see it's already here because the center defaultly is 0, 0, 0 again. So it just shrink in this way, right? It's shrinking in this way. So that's not what we want. We want to scale it in with the center of the square, right? Let's put a series into the factor first, right? So you see that's because the center is here, so it's scale. The top one is scaled to here. The bottom one is scaled to here. So it has this center scale. So the same thing as the rotation, we need to input the center for that. So we can grab the centroid here again, put it here. All right. And that's turn off the preview of the rotated one. Just leave this one. Right? We can change the thing here. Like for example, I want to start from 1. And here is, so the first one I don't want to scale. And the other things is keep scaling up because it's a 1 and you can check out a series. 1.1, 1.2, 1. Because it's a series number, right? You just create a series number of that. So here is a thing that we can do is to make it smaller. So we can start from the, how to go about it? We have to use this thing. Let's do a subtraction. So double click subtraction. I want to use a number, just 1. Oh, sorry, 2. 2 to subtract the thing I have. So I have that things. Sometimes I get a negative number, so that's not a good setting. I just want to make sure that this one can be a positive number. So what should we go about it? We do this thing into 0.01. We have smaller. Oh, sorry, I have to change the digit. Let's put small increment. Good. Oh, sorry, the minimum we have to go to 0. So I just want to have this smaller. So that will be incrementally slowly, right? So when I subtract it, sorry, it should be 0.5, 0.025. All right, that should be fine. And put a factor. What I just did is to adjust this number to make sure that the subtraction output, when I use 2 to subtract it, everything can be confined into 1 and 0, right? So that I just adjust this number. So I use the 1 as a start and the 0.025 as a step. So I can subtract it. We will talk about this part more. We will introduce an equation, all right? So, but anyhow, let's do this right now, okay? And now you have things in these. You are almost there. You can use loft. Just follow me. The loft. Directly put a geometry into it. You have a surface. Right? Does everyone have this tower? Let me know if you don't. We have to make sure that everyone has this tower. You don't?
I think I missed a step. I think
No, you're fine. Let me
or
see.
that I got a little confused.
Oh, this one go to here.
Oh, okay.
Yeah.
Mm.
Oh, here you don't have any step, so put it. Let's do.
Oh, okay.
Right.
Oh,
Everyone's good. You're good.
mine is like a spiral.
Oh, okay. Let me see. It's weird. Rotation. Okay, 95 degree. I think it's just reduced to 3.
I don't know why the
Yeah, because you are rotating too much. Yeah.
Okay, that makes sense.
Yeah. Okay. That's good.
Okay.
You all good? Yep. Mm-hmm.
0.
Oh, okay. So in this case, let's do this thing. So I use 2 to subtract it. And this would be, let's change the setting to 3-digit. More detail. Yeah. And 0.025. Oh, sorry. Let's change to 0 as a minimum. 0.025. Yeah. And just change the dimension. You're good?
Yep.
Okay. All right. Let's wrap up. So today is this. Before we go, save the file. This is the last thing we need to talk. Every time when you have this Grasshopper script and you Rhino, always save 2 files. One is Rhino file, one is Grasshopper file. So just like we said, here is a Rhino file. You have data associated with your Grasshopper, so you have to save it, even though it's just empty Rhino file. Still save it. So let's save the file. Save everywhere you like, but typically I just create a folder like a assignment 1, and I save them in the same folder. Grasshopper is the same thing. Save the document. I go to the assignment 1, save Grasshopper file, .gh file. So please keep it this as the thing we have to do, must do every time when you submit the work. Every time, save 2 files. One is Grasshopper file, one is Rhino file. Put them into the same folder. All right. Okay. Save. When you close your Rhino, you want to open it up again. Open a Rhino first. Instantiate the Grasshopper later. Use your Grasshopper to load your file. Don't open the Grasshopper file directly because remember we just put a square into Grasshopper, right? So when you open the Grasshopper but you don't have Rhino file, it will look for the data for the square, but it's gone because Rhino is not there. So it's a good manner to use Grasshopper and Rhino. Open the Rhino file first. And in Rhino you use Grasshopper command, instantiate the Grasshopper window, open the file in that window. All right. Okay, that's it. Let's call it a day. Any question? All right.